14F, we investigate more special angles. Last lesson, by the end of last lesson, we investigate the special angles when it is multiple of 90 degrees. They all lie on the axis, and we see the position on the unit circle, which is at the 1, 0, 0, 1, negative 1, 0, and 0, negative 1, those four positions. And I can evaluate sine, cosine, and tangent value for those angles. That's my type 1 special angles. Okay, I have type 2 special angles, which is 30, 45, and 60 degrees. Okay, not only those three angles. There will be something called related angles or reference angle. When an angle's reference angle is 30, 45, and 60, they are special angles. But we'll talk about more about the special reference angle later. Let's just have a look. Why 30, 45, and 60 degrees are special angles? As I said yesterday, special angles are those angles have this trig ratio as an exact, like we can express that in the exact form, like square root 2 over 2, like 1, like negative 1 or 0. I can express that in the exact form. Let's have a look. So 30, 45, and 60, which is pi on 6, pi on 4, and pi on 3. First, you need to know that. Those three angles will appear very often. So pi on 6, pi on 4, and pi on 3. Okay, just use 180 to divide 6, which will give you 30. Okay, why they are special angles? Because we have two special types of rectangles. Okay, we have two special types of rectangles. One is isosceles right angle triangle. Okay, see this triangle here is a isosceles right angle triangle. I'll say that's 90 degrees, that's 45 degrees, that's 45 degrees as well. Okay, just use a degree form and a radian form to make you used to it. Okay, so what is right angle isosceles right angle triangle? They have same length of the side and have hypotenuse. Okay, so I can just make one triangle. Okay, not necessarily like there's a lot of triangle like that. I'll just make it the easiest one. The easiest one can be with length 1, and this length must be root 2 because 1 plus 1, 2 square root 2, which is root 2. That's the hypotenuse using pi sec. Okay, this is one of those angles. Okay, this is one of those angles. We have 1, 1, root 2. And I know, doesn't matter what kind of right angle triangle you have, the sine 45 will always be the same. Okay, you only have one sine 45 value. You like in different angles, sine 45 will be the same ratio. So we can have a look. What is sine pi over 4? Okay. Sine pi over 4 is opposite over hypotenuse, which is 1 on root 2, which is root 2 over 2. Well, I can still use the unit circle to find out that value, but it's much easier in a right angle triangle we find out that value. Okay, it's much easier we did that. So we have root 2 over 2. And what's cosine pi over 4? Cosine pi over 4 is 1 on root 2 as well, and that is root 2 over 2. Okay, which is adjacent over hypotenuse is 1 on root 2 as well, which is root 2 over 2. And how about tangent pi over 4, which is the opposite over the adjacent? Okay, opposite over the adjacent, which is 1. Okay, in this right angle triangle, I can find the sine, cosine, and tangent pi over 4 values, which is root 2, and 1. Okay, which is root 2, root 2 over 2, root 2 over 2, and 1. Okay, we are not thinking about unit circle. We just purely think about this right angle triangle. Well, this is an isosceles right angle triangle with side length 1, 1, and the hypotenuse must be root 2. So I can find those ratios. And I'll put that in the table first. Okay, 1 on root 2, 1 on root 2, and 1. Well, I'm not going to write 1 on root 2. I'll write root 2 over 2 because that's easier to see later. I will show you a quick way to remember this later. Okay, let's write root 2 over 2. Okay, next triangle, special triangle we have is an equilateral triangle. Okay, it's an equilateral triangle. So if it's an equilateral triangle, all these lengths must be the same. Okay, all these lengths must be the same. And each angle is 60 degrees, which is pi on 3. Okay, each of these angle must be 60 degrees, which is pi on 3. Same as the top one, but I'm not going to write the top. And I'll say I'll just make any angle, okay, any length. I'll say the length is 2 because it's easier for me to calculate. You can say 1, you can say 3, you can say 10. It depends on you, but the ratio will be the same. I'll say that's all 2, 2, 2. What I'll do now is cut this triangle into half by a perpendicular line to the base. That's what I will do. I will draw a height to the base, cut this triangle into half. So this is not 2 anymore. That will be 1 and 1. Because this is an equilateral triangle, when you draw the height, you will bisect the base and perpendicular to the base. So you have 1 and 1 there. Okay, let's see this triangle here. Let's say that's ABC, triangle ABC. Okay, the angle ABC is 90 degrees. The angle ACB is pi over 3. How about the angle BAC? So what's the size of this angle here? What's that? 30 degrees. What is pi on 6? So I have this angle pi on 6 here. So in the right angle triangle ABC, I have pi on 6, pi on 3, and 90 degrees, which is 30, 60, and 90 degrees. I have the side length 2. I have BC 1. What do you think the length of AB will be? Use Passag. Hypotenuse is 2, so AB equals to square root of AC squared minus BC squared. Correct? Hypotenuse square, subtract the side square, square root equals to the other side. This equals to 2 square is 4 minus 1 square, which is 1. That gives you root 3. Okay, we have AB equals to root 3. Let's just look at the triangle ABC, which is a right angle triangle. Then I can find all the ratios. Let's target on pi on 6 first. What is sine pi on 6 in that right angle triangle? Which is opposite. The opposite is 1. Hypotenuse is 2, so which is 1 over 2. Then look at the cosine pi on 6 value. Cosine pi on 6, which is adjacent, which is root 3, over hypotenuse, which is 2. So it's root 3 over 2. And I have tangent pi on 6. Tangent pi on 6 will be the opposite, which is 1, over the adjacent, which is root 3. So it's 1 on root 3. And I'll rationalize that, which is root 3 over 3, times root 3 on both top and bottom, which is root 3 over 3. That's how I figure out the sine, cosine, and tangent value for pi on 6. Similarly, we can do pi on 3. So sine pi on 3 equals to opposite, which is root 3, over hypotenuse, which is 2. So it's root 3 over 2. Well, you can just look at your right angle triangle and write out those values. So cosine pi over 3, which is the adjacent, 1 over hypotenuse, 2. And tangent pi over root 3, which is opposite, is root 3 over adjacent, which is 1. So that is root 3. Okay. Let's put those values in the box. Okay, for sine that which is 1, 2, the next one is root 3 over 2, and last one is root 3 over 3. And for this column, that is root 3 over 2, 1 over 2, and root 3. Okay, that's the value for this table. Okay, there's 9 special values. Okay, it's 9 values. Well, the best thing you can do is remember them. Okay, remember them. Well, when I say sine pi on 6, you can directly tell me that's a half. Okay, when I say tangent pi on 6, you can tell me that's root 3 over 3. As a tangent 45, you can tell me that's 1. So that's the best thing you can achieve. Well, not necessary to do that if you really can't remember. I know students have difficulty of remember this a lot. Okay. Well, I really seldom can see someone answer that really quick. So the next best thing what you can do is remember the order of this table. When you deal with circular function questions, spend 5 seconds on setting up this table and then go back to the table and look at each value you need. How do we set up this table? Okay, the horizontal is the angle. Okay, horizontal is the angle, which is 30, 45, and 60, from the smallest to the largest. The vertical is sine, cosine, and tangent in this order. Okay, then let's have a look at the first row. Let's look at the first row. The first row, I have 1 over 2, root 2 over 2, and root 3 over 2. So what is that? Root 1 over 2, I can say that is a root 1 over 2. Okay, 1 over 2, I can say that's a root 1 over 2. So for the first row, the order is root 1 over 2, root 2 over 2, and root 3 over 2. So it's root 1, root 2, and root 3 over 2. You can directly write out the first horizontal line. Okay, root 1, root 2, root 3 over 2. And the next line, what is it? Root 3, root 2, and root 1 over 2. Okay, it's the reverse way. It's the reverse way. That's how you remember this. Well, I'm not asking you to remember that in your mind. Like, you can write down on the paper. Spend a really short period of time, write down on the paper, and every time you want to know some value, go back to that table and look at it. Okay, that's the second row. And the third row is, you know what is tangent. The tangent is the sine divided by the cosine. Okay, it's the sine divided by the cosine. So 1 over root 2 divided by root 3 over 2, you will have 1 on root 3. So which is root 3 over 3. You just need to do a division. Root 2 over 2 divided by root 2 over 2, same thing, you will have 1. Root 3 over 2 divided by half, which is times by 2, you will have root 3. That's how you find the third row. Okay, first row is root 1, root 2, root 3 over 2. Second row is root 3, root 2, root 1 over 2. And the last row is the first row divided by the second row. You find the third row. Okay, so you can write out this table really quick. That's the second best thing you can do. Or what you can do is remember how do we find this table, these values. Okay, it's using those two right angle triangle. Remember those two right angle triangle and apply that. Okay, and apply that. So that's the third thing you can do. Okay, remember the shape of those two right angle triangle. Remember all the angles, remember the length opposite to that, and then work out the sine cosine values from the right angle triangle. Okay, 3 ways you can do it. Directly memorize it, memorize the table, write down on the paper, or remember the right angle triangle itself, and then find out the value every time. Okay. But anyway, you need to find a way to do that because you won't be providing tables in your part 1 exam for those exact values. You definitely need to remember those exact values. And there's a lot of evaluating questions like this. Okay. The next thing we talk about is the second type of special angles. Exact values, okay, that's the exact values, can be found when first, the angles, reference angle are 30, 45, and 60. That is actually type 2. And this is the bottom one is type 1. So there are two types of special angles. One type is the multiple of 90 degrees, or I can say that's multiple of pi on 2. The second type is when the reference angle, okay, highlight the word reference angle. So when the reference angle are 30, 45, and 60. So what is reference angle? Then the question is, what is the reference angle? Okay, I will just show you the reference angle for the first three, okay, for the first three. Well, don't worry about what the question is asking. Now we're just aiming for finding the reference angle for 210. Okay, what is the reference angle for 210? What you need to do is draw a Cartesian plane and show where is 210. Okay, show the angle 210. Just find it, where is it? Okay, from here to here, that's 210 degrees. Reference angle is the angle in between 0 and 90 degrees. Okay, it's the angle in between 0 and 90 degrees. So the reference angle is the angle line. So what is the angle line? The angle line is this blue line here. Okay, this angle line. Formed by this angle line and the x-axis. And the x-axis, never be y-axis. Okay, someone tell me is this angle here, but it's not. It's not making with y. It's always making with x. So you can see that the angle has been made is this. Okay, this is the reference angle. It's the acute angle forming by the horizontal x-axis and the angle line. That is the reference angle. What's the size of this angle? What's the size of this angle? If that's 210, 30. Okay, 210 minus 180. So that's 30 degrees. So the reference angle for 210 is actually 30 degrees. Okay, let's have a look at 150 now. Okay, same thing. Let's draw a Cartesian plane and okay, draw a Cartesian plane and label 150. Have a think about where is 150. 150, where is that? Okay, it's this angle here. Yep. So the reference angle will be this blue line make with x-axis, and it's the acute angle. So it must be this angle here. It must be this angle here. And that angle is 30 degrees. Okay, 180 subtract 150. So 150 degree also has a reference angle of 30 degrees. Well, it's possible, nothing wrong. Okay, there can be infinitely many angles have the same reference angle. If it's a reference angle, okay, most of the angles can share with one reference angle. So 210 get a reference angle of 30, 150 get a reference angle of 30 as well. And you can do the last one, 330. Where is the reference angle? Okay, one thing is to remember, reference angle is made with x-axis, not y-axis. Well, even though I emphasize it now, like someone's still trying to find with y-axis, it happens a lot because I actually observe my students doing this a lot. Okay, they're just unconscious, like, oh, that's a small angle, it looks right, and then that is making with y-axis, and they assume that is the reference. It's not. It must be made with horizontal line. Okay, 330. 330 is passing to 70 and it turns to fourth quadrant, which is this angle here. Okay, start from here to here, that's 330 degrees. What is the reference angle? 30 as well. Okay, horizontal line, this angle line is the angle here. And it's 360 subtract 330 and that is 30 degrees here. I'll just do one more with you, okay? Because they are all in degree form, but those three are in the radian form. Okay, can you tell me where is 5 pi over 4, in which quadrant? That has 6 6 quadrant. We don't have 6 quadrant, we have 3rd quadrant. I was thinking I hear something wrong. I was like 6. Okay, 5 pi over 4. You can say that's a pi plus pi over 4. Okay, so pi plus pi over 4. So pi is actually 180, is half cycle. And then go a little bit down, a little bit down here, which is this angle here. So the reference angle will be this one. What is that angle? What is that angle? Pi on 4. Okay, I'll give you a suggestion here. I know you feel quite uncomfortable when you first deal with radian form. You can't see how large is it. You can't see where is it. But like, do not worry. Like, do not turn that into the degree form. Okay, do not try to see what is that angle and then try to work from the degree form and then turn back into the radian form. It takes so long. Okay, what you need to remember is pi on 2, pi, 3 pi over 2 and 2 pi. Okay, that's the position. We have 0, pi on 2, pi and 3 pi over 2. And the other 3 angle you need to remember is pi on 3, pi on 4 and pi on 6. They are 60, 45 and 30 degrees. That's what you need to remember. You know that is not passing pi on 2 yet. It just turns 30, 45 and 60 degrees. Okay, that is what you need to remember. Do not convert that into degree. For example, what I'm working on this is like, when you ask me, how many degrees is 5 pi over 4? I actually don't know that. Okay, so when I see this angle, I'm not converting back into degree form. Okay, unless you ask me to do so. What I'm thinking is, this is pi plus pi over 4. Okay, this is pi plus pi over 4. So pi is half cycle here, and I keep going for pi over 4. That is not passing one quadrant yet. So it's 45 degrees, it's halfway through. Okay, it's halfway through. So that's how I work on this. You need to get used to it. Do not try to convert back, it takes so long. So the reference angle for this one is pi on 4. Okay, the reference angle for this is pi on 4. Okay, I think now you fully understand what is a reference angle. And the next step, what we're going to do is to evaluate those. Okay, cosine 210. You said there's a reference angle 30, but what is this 30 degree actually do for you? Okay, what is this 30 degree actually do for you? So when you're trying to find the sine, cosine, and tangent for some large angles larger than 90 or less than 0 degrees, well, when the angle is not in between 0 and 90 degrees, you need to use the reference angle to calculate. So the first thing what we need to do is directly change the angle inside, become the smaller reference angle. We don't want the big angle, we want the angle within control, which is 0 to 90 degrees, which we most familiar with, okay, which is 30 degrees in this case, okay, is the reference angle. But it's not finished. You can't say like all the angle with the same reference angle got the same value, okay, it's not going to be true. Then, well, that's the first step we do, and we just need to do another small thing is to decide the quadrant which this angle is in. The cast, okay, CAST. CAST, what is this quadrant, this angle in? The third quadrant is whose quadrant? 10. Okay, this is tangent's quadrant. What does T means? What does T means? Like, why we write a T here? Well, only 10 is positive. Okay, cos and sine will be negative. So if sine and cos will be negative, this is looking for cos. I will put a negative in the front. That's the next thing what we need to do. Okay, that's the next thing what we need to do. We have a negative. So what's negative cosine 30? What's cosine 30? It's not half. Root 3 on 2. Root 3 on 2, which is pi on 6. So root 3 over 2. That's a negative root 3 over 2. Okay, that's a negative root 3 over 2. Alright. Just do this example with you. This example below here. Okay, cosine 5 pi over 4. So I will do, that's a cosine pi over 4. Change 5 pi over 4 into pi over 4. And this is again the t quadrant. The third quadrant is the t quadrant. Again, cosine will be negative, so it's negative cosine pi over 4. And what's cosine pi over 4? Everyone think. Guess. 2 on 2? Root 2 on 2. Okay, negative root 2 on 2. Okay, every time, do not just go back and like if you do more questions, if you think every time, even though you make mistakes, that can make you remember that faster. Okay, every time you just need to think a bit. Okay, so use the similar idea to finish the rest 4 questions for me, please. Should be really quick, give you 2 minutes. Those 4 questions. 2 of them already find out the reference angles. You can directly use that. We almost up to graphing. That's the terrible part. We can still enjoy this lesson. This is still fun. Or we'll go back first and then keep going. We'll go back to the first 2 pages and then go to the sketching. Not going to start sketching. Okay, everyone try those 4 questions. have enough time? Okay. For B, I have sine 150 into sine 30. And then it is the sine quadrant. I still have plus sign. And that's positive a half. For C, change the angle into 30, but I stay in the cosine quadrant. That is a negative for tangent. So I have negative tan 30. So tan 30 is root 3 over 3. It's a negative root 3 over 3. And I have sine 11 pi over 6. Well, when you sketch this angle, you will think about 12 pi over 6 will be 2 pi. Okay? Will be 2 pi but less than that for a bit. So less than pi on 6. So you will have angle pi on 6 there. You will turn backwards for pi on 6. Okay, so you have the reference angle pi on 6. It is the cosine quadrant. I'll have negative values, so I have negative half. Okay, last one, 7 pi over 4. Again, you think about 8 pi over 4, which is 2 pi. You turn back for pi on 4. The reference angle is pi on 4. It is the cosine quadrant. You have negative 10 pi on 4. And tangent pi on 4 is 1. You have negative 1. Okay, hopefully everyone can get the correct answer. Okay, it's not a hard part. When you know the method, it will be really easy. Okay, that's how you evaluate all these angles. Okay, let's go back to exercise 14E, which is page 3. So we are talking about the symmetry properties of circular function. Okay, what means by symmetry properties? When you have angle in two different quadrants and they are symmetrical angles, for example 30 degrees and 150 degrees, they are the symmetry angles. Okay, what's the relationship between them for sine, cosine, and tangent values? First, I'll just let you know for steps for evaluation is written here. Okay, so the method you use to evaluate the exercise you just did is following those steps. Okay, the method is here. So it's doing how do you do those questions. Okay, how do you do those questions? The method is here because I was planning to teach that first, but I changed my mind. So your method is here. You can make a note here. Okay, example 1. We use the similar idea to find the formula. So have a think. There are 4 symmetrical angles: pi minus theta, pi plus theta, 2 pi minus theta, and minus theta. There are 4 angles, and you have 3 trigonometry ratios for each of them. So there are 12 formulas. You are not going to remember 12 formulas. Okay, I'll give you a method, and you know how to do it, and you can find out that by yourself. So let's have a think about pi minus theta. Just assume theta is an acute angle. Where this angle will approximately be, like in first, second, third, or fourth quadrant, which quadrant it will be? Pi minus theta. Second. So if it's in the second quadrant, let's just sketch it below here. Okay, just assume any size in between 0 to 90 for theta. So that is, I would just say that's pi minus theta. Okay, this angle here. That's pi minus theta. Okay, it's not reaching pi. So what do you think the reference angle will be for this angle? In terms of theta. What is the reference angle for this angle? Theta. Theta is this angle here, right? It's this angle here. Well, is the angle line make with the x-axis, and it's pi. Okay, I turn this much as pi, but I need to minus theta. I will go back to theta degree as well. So this angle is actually theta. Okay, this angle is actually theta. So I'll turn back for theta degrees. So this angle is theta. The reference angle is theta. As I said, okay, what this formula means. This formula means I want you to tell me what sine pi minus theta equivalent to. So what sine pi minus theta equivalent to? You have the angle, which is bigger than 90 degrees. I will change that into smaller angle, reference angle, which I will change that into theta, because theta is the positive angle, which is less than 90 degrees. Okay, that's how we did it. And because this is the sine quadrant, sine will be positive. So sine pi minus theta will be just sine theta. Yeah. Sine pi minus theta will be just sine theta. That's what you need to write. And very similar idea, cosine pi minus theta. Cosine pi minus theta will be cosine theta because the reference angle will be the same for the same angle. But this is the sine quadrant. I need to put a negative sign here. And tangent pi minus theta is still tangent theta, but it still is the sine quadrant. I have negative sign here. Okay, I need to find the reference angle for bigger angles. Okay, if the angle is not in the first quadrant, you need to find the reference angle. And you find the reference angle, instead of the larger angle, you write the reference angle, and then you can just evaluate in this way. Think about which quadrant it is in. Okay, it is in the second quadrant, which is the sine quadrant, therefore only sine positive here. Okay, the next one, pi plus theta. Which quadrant this will be in? Third. So I will have angle here. Okay, that's pi plus theta. So this is the reference angle. What's the size of that? Theta again. So it's still theta. It is still theta. Whose quadrant is this? 10. I have 10 CAST. I have 10 here. So I change everything to theta. Okay, sine theta, cosine theta, and tangent theta. Only 10 positive. So sine and cos will all be negative. Okay, sine and cos will all be negative. Next thing is 2 pi minus theta. Okay, 2 pi minus theta. Which quadrant is in? Third or fourth? Fourth. Okay, 2 pi is the full cycle angle back for theta. It's the fourth quadrant. So fourth quadrant is here. Okay, if I said that is the 2 pi minus theta, and I can see a reference angle here. What's that? Theta is again still theta. And whose quadrant is that? Cos, C. So sine will become theta, cos theta, tan theta, but only cos positive. So sine and tangent will be negative. And the next thing is minus theta. I want you to have a think. What's the connections between those two angles? Like, is there any relationship between them? They're both in the fourth quadrant, that's correct. Think about minus theta. If I add a 2 pi at the back, is that looks exactly the same as the front one? Okay, it's exactly the same. Do you remember I said angle can adding 2 pi, 4 pi, 6 pi, or subtracting 2 pi, 4 pi, 6 pi, they will still be the same angle. So it's identical. Okay, it doesn't matter if you add 2 pi, it won't change the value. So if I add a 2 pi, that looks identical as this one. Oh. It looks identical to that one. Therefore, all the sine, cosine, and tangent value will be the same. So this one will share the same value as the front one. Okay. And also have a think about what is minus theta. Like if you can think about the position. The position is just from the 0 place, go clockwise for theta degrees, which is here. Okay, this direction, because it's turned this direction, I will say that's a minus theta degree. But what is the reference angle? Theta. It's just the absolute size of this angle, so which is still theta. So I will have exactly the same graph as the previous one. Okay, they are identical. So that's why those two columns has the same value. Okay, same formula. So that is just symmetrical property. Okay, that is just symmetrical property. When pi minus theta, pi plus theta, and 2 pi minus theta, okay, they're at the symmetrical position. And do not try to remember all of that. I can't remember all of them. Just use the graph to help you to find out the value. Well, there will be like very random 1 or 2 questions like in every 5 years. Like it's quite hard. It's kind of quite dry stuff. This is the formula. You know that or you don't know that. Well, they not really have harder ways of testing it, and it's quite waste of mark to allocate 1 mark there, which is purely remembering formula or purely just calculating formula out. So they not really like this topic, but you still need to know this content because it's still in the study design. There's a possibility you will be asking that. But if you ask me, the proportion of question appeared is very low. Well, there's not much question like this type. Okay. What they use is like the following question here in multiple choice. Okay, it can appear in multiple choice. So give you sine x equals to 0.6. Ask you what is sine pi minus x equals to, and give you 5 options and ask you to choose one. But they are really easy ones. Yeah. So sine pi minus theta. Let's just, because we just work out that. So pi minus, that is just equals to sine x, right? We use the formula and it's just sine x. Okay, see above pi minus x, if x is an acute angle, it just go back a little bit. And the reference angle is still x. It is in the second quadrant, so it's positive, that's sine x. So what is sine x? That's 0.6. So sine pi minus x is 0.6. That's the way they will ask about this type. There will be a more important formula later, next lesson I will talking about. That will appear more in the VCA exam. Okay, not this time. Okay, sine pi plus x is in the third quadrant, is the tangent quadrant. So sine will be negative. So it's negative sine. The reference angle is x, so it's negative sine x, which is negative 0.6. 2 pi minus x, 2 pi is go a full cycle and go back for x. The reference angle is x. That's the fourth quadrant, which is the cosine quadrant. You will have negative. Okay, so it's negative sine x. That is negative 0.6. And sine minus x will be minus sine x. And that is minus 0.6 as well. Okay, something like a quick formula you might remember is the last row here. Okay, you might want to remember the last column here. So what the last column is talking about is sine minus theta equals to minus sine theta. Cos minus theta is just positive cos theta. And tan minus theta is a minus tan theta. That is what you might want to remember. Okay, just a quick formula. So the negative will be taken out from the bracket for sine and tangent, but will just disappear in the cosine one because the fourth quadrant for cosine is still positive. Okay, that's the last column of the formula. Well, we use that the most. Okay, we use that the most. All right, I can't finish the last exercise, but it's fine. I will just spend about 10 minutes on next lesson, and I will start focusing on how to sketch sine graph. So try to attend the next lesson because it will be a very important lesson. Okay, the next one will be a very important one. Okay, I'm more talking about to the one who has been in Melbourne High do the rehearsals. Come to class next period.